Welcome back, everyone, for another deep dive.
Yeah.
And this time, we're going to be talking about algebra and becoming like your kid's sidekick in algebra.
Yeah.
And I think that this is...
With no capes required.
No capes required. That's right.
No capes.
We're going to unpack all the ways.
Well, some of the ways.
You can be a math hero to your kid, even if you don't feel like one yourself.
Yeah. That's the great part about this, is that anybody can do this.
Right.
You know, it's not about being able to solve all the complex equations or anything. It's more about just showing your kids that algebra is really a superpower for everyday life.
Yeah, and I think that so many of us as parents have stared blankly at our kids' homework and been like,
oh, absolutely.
when are they ever going to use this?
And will I ever use this?
Right.
Yeah.
And so we're going to be looking at the book Heroes today.
Yes.
Which is a book specifically for parents who want to support their kids in learning algebra.
It's a great resource.
Yeah, and I think that even if you're not a parent, or your kids aren't tackling algebra yet, or even if you're the one who needs the refresher,
Oh, yeah.
like I do,
Absolutely.
you know, these are the really fundamental ideas that are useful for everyone, not just in school, but in life.
That's true.
So let's get started.
Okay.
What is algebra, really?
Right.
I mean, is it just a bunch of X's and Y's meant to torment us?
You know, it seems that way sometimes, but it's way more than that. It's about logical thinking and problem-solving skills that we use all the time.
Okay.
Without even realizing it.
Yeah.
You know, so like figuring out how much paint you need to redecorate a room or how to adjust a recipe to feed more people, that's algebra.
Okay. So you're making it sound a little bit less scary.
I hope so.
Yeah. But I do remember when I first encountered variables, expressions, and equations,
Right.
feeling a little bit lost.
Yeah.
Can you break those down for us like you're explaining it to a 10-year-old?
Absolutely.
Okay.
So imagine making a cake. Okay. You have your recipe. That's kind of like an expression, and it has ingredients like flour and sugar, and those are like constants because their amounts stay the same.
Mm-hmm.
But then you have something like the number of eggs, which could change depending on how big of a cake you want.
Okay.
That's like a variable, and we represent that by a letter like X because its value can vary.
So if my recipe says 2x plus 3 cups of flour, the X is how many eggs we decide to use.
Exactly.
Okay.
Now, an equation is like saying this cake recipe will make 12 servings.
Okay.
It's a statement that two things are equal, so we could write it like this 2x plus 3 cups of flour equals 12 servings.
So that's when we solve for X to figure out how many eggs we need for 12 servings.
Precisely, and that's where the problem-solving fun begins.
That's right.
Yeah.
The fun begins.
Yes.
Okay, so Heroes talks about collecting like terms as a superheroic feat.
Oh, yeah.
Can you explain what that means and not make our heads spin?
I'll do my best.
Okay.
So think of it like tidying up a playroom. You're not just going to shove all the toys in a box randomly. You're going to group similar toys together, right?
You're going to organize.
All the blocks in one bin, all the dolls in another.
Right.
That's what collecting like terms is all about. It's grouping similar things to simplify the mess.
Okay.
Yes.
So instead of toys, we've got variables and constants.
Exactly. So for example, if you see 2a plus 3b plus 5a plus 4b plus 1,
Okay.
the a terms are like blocks, the b terms are like dolls, and that one is like a lone stuffed animal.
Okay. I get you.
Right. And so we add or subtract the numbers in front of them.
Okay.
Those are called coefficients. It's like counting how many of each toy you have. So 2a plus 5a becomes 7a.
Okay.
3b plus 4b becomes 7b, and that lone one just stays put.
Okay.
Yeah.
So then we end up with 7a plus 7b plus 1.
That's right. It's
Yeah.
like having a nicely organized playroom.
Right. Which is always the goal.
Exactly. And you know what? That simplification that we just did makes it much easier to work with those expressions when we solve equations later on.
Okay.
Yeah.
Now, substitution to me sounds a little bit like a magic trick.
It does. It does.
It's almost like giving these variables secret identities.
That's a great way to put it. So remember our cake example.
Yes.
Substitution is like saying, okay, let's decide that we want to use 2 eggs.
Okay.
So we're substituting the X with the number 2.
Okay.
Yeah.
Can you give us a real-world example, maybe one that kids can relate to?
Let's say your child wants to buy a video game that costs $60 and they're saving $5 a week from their allowance.
Okay.
Okay. We can represent their total savings with the expression 5x, where x is the number of weeks.
Okay.
If they've been saving for 4 weeks, we can substitute x with 4 to find out how much they've saved so far.
So 5 times 4 equals $20. They're getting there.
They're on their way, right?
This is making substitution feel a lot less abstract,
Good. I'm glad. And as they save more, you can keep substituting different values for X to track their progress.
Yeah, I'm seeing all the ways that we use algebra every day and we don't even think about it.
That's the key takeaway, I think.
Yeah.
Algebra is everywhere.
Yeah.
And the more we can show our kids those connections,
Right.
the less daunting it will feel for them.
Yeah, okay, so are we ready to move on to something a little more challenging?
Let's do it.
Okay, how about multiplication and division?
Okay.
With all these algebraic terms, because I always found this to be a little bit trickier.
Yeah, they might look a little trickier, but there are some simple rules to follow.
Okay.
And remember, we're just aiming to break these concepts down so that anybody can understand them.
Right.
So let's say you have a rectangular garden bed.
Okay.
And you want to calculate its area.
Okay.
One side is 3x feet long, and the other side is 4x squared feet long.
Okay, so to find the area, we need to multiply those sides together, 3x times 4x squared. But how do we do that with all those x's in there?
We multiply the numbers in front. Those are called the coefficients. Just like usual, 3 times 4 is 12.
Okay.
And then for the x's, we add their little exponents.
Okay.
Okay, and if an x doesn't have an exponent, it's like it has an invisible one.
Okay.
So it's x to the first times x squared.
So what do we get when we add those exponents?
You get x cubed.
Okay.
So the total area of our garden bed is 12x cubed square feet.
Got it.
Okay.
What about division? Does it work similarly?
It does. Let's imagine we have 12 cookies represented by 12x cubed, and we want to divide them equally among 4 friends represented by 4x.
So we divide the coefficients 12 divided by 4 is 3. What about the x's?
We subtract their exponents this time. So x cubed divided by x to the first leaves us with x squared.
So each friend gets 3x squared cookies.
Exactly.
I'm starting to see the patterns here.
I told you there were patterns there.
Yeah.
That's what algebra is all about, is recognizing and applying these patterns to solve problems.
Okay, this is starting to feel way less intimidating. Okay, so what's next on our algebraic adventure?
Let's unlock some hidden treasures, as our source material puts it, by expanding brackets.
Okay, I'm intrigued in favor. Give us a real-world scenario where we might need to expand brackets.
So imagine you're buying party favors for your child's birthday party.
Okay.
Okay. You want to give each guest a bag with 3 stickers and 4 candies.
Okay.
If you have X guests, you can represent the total number of items in each bag with the expression 3 plus 4.
Okay, so that's like saying each bag has 7 items.
Right. But to figure out how many stickers and candies you need in total, you'd multiply the number of items per bag by the number of guests.
Okay.
So it would be X times the quantity, 3 plus 4. That's where expanding brackets comes in.
Okay, so how do we do that?
So we multiply the X by both the 3 and the 4 inside the brackets. It's like we're giving each guest X sets of stickers and X sets of candies.
So it becomes 3x plus 4x.
Exactly. Now we know that we need 3 X stickers and 4 X candies for the party.
Okay. I'm starting to see how expanding brackets helps us really break down the problem and see it more clearly.
It's like unpacking a suitcase. You're revealing what's inside and organizing it in a way that makes sense.
I like that analogy. Okay, what about factorization?
Oh, okay.
Is that kind of like packing everything back into the suitcase?
You got it. It's the reverse of expanding brackets.
Okay.
We're looking for common factors. It's like finding all the clothes that belong together.
Okay.
So let's say you're organizing your child's art supplies. You have 6 crayons and 12 markers represented by the expression 6x plus 12.
Okay.
All right?
So how do we factor that? What's the common factor we're looking for?
In this case, the highest common factor is 6. It's like saying we can group those art supplies into sets of 6.
Okay, so then we could rewrite the expression as 6 and then in parentheses x plus 2.
Precisely, we've factored out that common factor of 6,
Okay.
which helps us see the underlying structure of the expression.
So it's like we're putting all the crayons in one container and all the markers in another container, but they're both labeled with a 6 to show that they go together.
Exactly. And just like with expanding brackets, factorization makes expressions easier to work with, especially when we're solving equations or tackling more complex problems.
Right. Okay. This is starting to feel like we're putting together an algebraic toolkit.
Yes, we are.
Yeah.
One concept at a time.
One concept at a time. And the more tools we have in our kit,
Yeah,
the more confident we'll feel tackling any algebraic challenge that comes our way.
absolutely.
Okay, so
We're on our way.
yeah,
We're going to be algebra heroes.
we're on our way to becoming algebra heroes.
That's right.
All right, so stay tuned. We're going to take a quick break, and we'll be right back.
All right.
Okay, so let's add another tool to our algebra toolkit.
Yes.
Before we were talking about sequences, those chains of numbers with a hidden code, the common difference.
Right, and remember, it's not just about recognizing the pattern, it's about being able to predict any number in that sequence, even like the 100th one, without writing them all out. That's where the nth term comes in.
Yes, the nth term. This sounded a little intimidating before. Can we crack the code on how to find that?
We can. It's actually quite logical once you break it down.
Okay.
Okay, remember our detective analogy?
Yes.
We need clues. So the first term, which we'll call A, and the common difference, which we'll call D.
So in our example, before 4, 7, 10, 13,
Yeah.
A would be 4 and D would be 3.
Perfect. Now, imagine building a tower with blocks.
Okay.
The first level has a blocks.
Got it.
You get to the next level, you add D blocks.
Okay.
The third level, add another D blocks, and so on.
So each level is like a term in our sequence.
Exactly. Now, to find the number of blocks on any level, say the nth level, we can use this formula.
Okay.
Nth term equals A plus the quantity n minus 1 times D.
Okay, so let's unpack that. We've got our starting point, A plus.
Yeah.
Why is it n minus 1?
Think of it like this. To reach the nth level, you've added the common difference D a certain number of times, but not n times.
Right.
You've added it one less, hence n minus 1.
So for the 10th level, we've added D 9 times.
Exactly.
I see. Okay, so let's try with our sequence, 4, 7, 10, 13. What's the 10th term?
Okay, so we know A is 4, D is 3, and we want the 10th term, so n is 10.
Right.
So plugging those into our formula, 10th term equals 4 plus the quantity 10 minus 1 times 3.
Okay, so parentheses, first 10 minus 1 is 9.
Yes.
9 times 3 is 27.
Keep going.
And 27 plus 4 is 31.
Exactly. We found the 10th term without listing all the numbers.
Right.
Now imagine how helpful this could be for your child if they're asked to find, say, the 50th term.
No more tedious counting.
Exactly. They just plug the numbers into the formula.
It's like a cheat code for sequences.
It is. Yeah.
Okay, but how can we connect this to real-life situations for kids?
Well, think about savings. Let's say your child is saving for a bike that costs $200.
Okay.
They start with $50 and save $15 each week.
Okay.
We can use a sequence to track their savings.
So the first term A would be $50. Their weekly savings D would be 15.
Right. If they want to know how much they'll have saved after 8 weeks, we can use our nth term formula where n is 8.
So it would be 50 plus 8 minus 1 times 15.
You got it.
That's $155.
Exactly. And they can use this formula to figure out how many weeks they need to save to reach their goal.
Right.
It's a practical way to see sequences in action.
Okay. This is starting to make a lot of sense.
Good.
Um,
Yeah.
Algebra isn't just about abstract formulas.
Mm-hmm.
It's about giving kids tools to understand patterns and solve problems,
That's right.
even financial ones.
Exactly. And the best part is we can show them how these concepts are relevant to their own lives, their own goals.
Right. Okay, so now I'm kind of excited to talk about our next topic, which is linear equations.
Okay.
That sounds a little bit like we're back in detective mode.
It is a bit like solving a mystery.
Okay.
Remember those equations where two expressions are equal? Solving linear equations is about finding the value of the variable that makes that statement true.
So we're finding the missing piece of the puzzle to complete the picture.
Exactly. And remember those inverse operations we talked about earlier.
Yes.
Those are our trusty tools for solving these mysteries.
Okay, so I'm ready to channel my inner Sherlock Holmes.
Let's do it.
Okay.
Yeah.
Let's work through an example to see how these inverse operations work.
Okay, let's say your child is planning a movie night with friends and has a budget of $20.
Okay.
Each movie ticket costs $5, and they want to buy popcorn for X dollars.
Okay, so we can set up an equation to represent this.
Right.
5 times the number of tickets plus X for popcorn equals $20.
Perfect. If they're inviting 3 friends plus themselves, that's 4 tickets.
Okay.
So our equation becomes 5 times 4 plus X equals 20.
Okay, so that's 20 plus X equals 20.
Right now, to find out how much they can spend on popcorn, we need to get X by itself.
Right.
What's the inverse operation of adding 20?
Subtracting 20.
So we subtract 20 from both sides of the equation.
Okay, so it's 20 plus X minus 20 equals 20 minus 20.
Exactly. And that leaves us with X equals 0.
Oh, no. Does that mean they can't afford any popcorn?
Well, it means they've spent their entire budget on movie tickets.
Okay.
Maybe next time they can adjust their plans.
Right.
Invite fewer friends or choose a cheaper snack.
This is a great example of how linear equations can help kids make real-life decisions, even if the outcome isn't always what they hoped for.
It's about using math to model situations, to explore different possibilities, and to make informed choices.
This is making me realize how much we can empower our kids by helping them understand these concepts.
Absolutely, but it's also important to remember that we don't have to be math whizzes ourselves to support them.
Right.
It's about creating a positive learning environment, encouraging curiosity, and showing them that math is all around us, not just something confined to textbooks.
Okay. Okay, welcome back to our algebra adventure. I don't know about you, but I'm feeling a lot less intimidated by those X's and Y's now.
That's the goal. And remember, you don't need to be a math expert to help your child succeed in algebra.
Right.
It's all about fostering a love of learning and showing them how these concepts connect to the real world.
Right. We talked about breaking down complex problems, using those inverse operations, and even applying algebra to real-life situations.
Right, like budgeting and planning.
Right.
And one of the most important things I think we can do as parents is to encourage a growth mindset.
Okay.
You know, math can be challenging sometimes.
Right.
And it's okay for kids to struggle.
Yes.
So instead of getting frustrated when they hit a roadblock, we can help them see it as an opportunity to learn and grow.
So we can model that as parents.
Exactly. We can model that ourselves, by being open about our own struggles with math,
Right.
or even tackling new math concepts alongside our kids.
I love that idea. It turns it into a team effort.
Yes, a shared challenge.
Yeah. Okay, so what are some ways that we can support our kids when they're actually working on algebra problems?
One approach is to encourage them to talk through their thought process out loud. So, ask them questions like, what's the first step you're going to take? Or why did you choose that operation?
So we're like math coaches.
Exactly. You're guiding them through the game plan.
Yeah, and it helps them to clarify their thinking.
It does. It also helps us to see where they might be getting stuck or where they have a strong understanding.
Right, and I've also heard that it can be helpful to relate those abstract concepts to something more concrete, something they can visualize.
Absolutely. Remember our earlier analogy of collecting like terms as tidying up a playroom?
Yes.
Visual aids like that can make a huge difference.
Or using blocks to represent variables when they're solving equations.
Exactly.
That makes it tangible.
It does.
Yeah.
And don't underestimate the power of real-world applications.
Right.
We've talked about budgeting and planning, but there are so many possibilities.
If your kid's into sports, you can have them analyze statistics.
Absolutely. Calculate batting averages.
If they're into baking, you can talk about ratios and proportions.
Right. The key is to find those connections, those sparks of interest that make algebra feel relevant and engaging.
Well, this has been a very insightful deep dive.
It has.
I feel like we've not only demystified algebra, but also kind of discovered its hidden power and even its fun side.
I agree, and I hope our listeners feel empowered to embark on their own algebraic adventures with their kids.
Yes, and remember, you don't have to be a math whiz to be a math hero.
That's right.
It's all about encouraging curiosity, celebrating those aha moments, and just showing your kids that algebra can be a superpower that they can use to navigate the world around them. Thanks for joining us for this deep dive into algebra. Until next time, keep exploring, keep questioning, and keep rocking at math.